The tool may be logged out when you get to it. If it's logged out, this section will be empty. If that's the case, click this key, then enter the username and password pen_operator. Next, let's see how to run the tool. First, we run a pre-cleaning process, such as pre-lot deep or pre-lot smooth. Then we can run our etch. And then we must follow that up with another cleaning process, such as IPC deep or IPC smooth. If we'd like to run another etch on another wafer, we'll need to run another cleaning process afterwards. We can repeat this as many times as are needed during our reservation. So now, let's start running the tool. Before running the pre-clean, we should check the mechanical strength of the wafer first. Click Transport, and click Vent, and we'll wait a bit. And now the load lock is vented, as this message shows here. These cleaning processes use SF6, which will etch the cleaning wafer over time. If the wafer is weak, it might break inside of the tool, and you'll have to cancel your run early and report the problem to staff. Let's take the wafer out and stress test it like this. There's no exact way to tell if the wafer is weak enough, but you'll be able to feel if the wafer needs to be replaced. Once you've checked the wafer, put it back in the load lock. When you put the wafer into the load lock, make sure to line up the major flat with the back of the robot arm and close the lid. Let's run our pre-clean process now. Grab the mouse, go to the sequencer, click this button here to cancel the last sequence, click this pointer button, and now you will see a long list of sequences. For this process, we're going to run the sequence pre-lot deep. Let's select that one and click OK. Then we click the play button, select these, and then we're on our way. If you click here, this will show you what the tool is doing inside the process chamber. You can see which step it's on here, gas flow rates, and so much more. Here we'll have a few minutes before we can run our process. So let's take this time to set it up. Click back here, and then here, so we can edit our process. This tool is a bit different from most other tools that you might run. We don't run recipes on this tool, instead we run sequences. A sequence is a recipe of recipes, which tells the tool to run the other things it needs to run in addition to the process itself. Let's look at an example. Let's take this sequence called 0 mets deep and open it. You'll see here what it contains: idle the chamber, load the wafer, run the process, and so on. We need to adjust the parameters of this recipe, called the module recipe, which is the etch recipe that the tool will actually run on the wafer. Let's go ahead and do that now. For this example, we'll set this 0 mets deep recipe to run for 50 loops. Let's close out of this. Now we need to go to Module, Wrap, and find our module recipe and open it. Whoa, that's a lot of stuff. There's a lot here, so we should only edit exactly what we need to, which is the loop count. You can find that here if you scroll all the way to the right and down, and here we go. In order to edit the module recipe, we have to change its class to Development, and then make our edit, then save it, then switch it back to production. So let's do that. Click Reclassify, Development, and OK. Open it, and now we can edit the recipe. Scroll over and change the loop count. Save it, and exit, and reclassify it back to production. And there we go. Now the process is ready to run. Just reclassify it back to production, and we're ready to go. If you're using a timed etch, the procedure here is the same, but the etch time can be found in the recipe. Once our pre-clean process finishes, the tool will unload the wafer back into the load lock and vent it. Remember that your process wafer must be very, very clean. Use the lamp next to the tool to check your wafer one last time for particles on the backside. If you tilt the wafer at an angle, you can see particles from beta wipes in the lab. If it's still a bit dirty like this, find an alpha wipe and brush them off your wafer. Put your wafer in the load lock. Remember to line up the major flat, close the lid, and run our sequence. This work was performed at the Singh Center for Nanotechnology at the University of Pennsylvania, a member of the National Nanotechnology Coordinated Infrastructure (NNCI) network, which is supported by the National Science Foundation. Thank you.